In this example, we're going to find domain of radical functions. And as you can see from this example, there are quite a few different types of ways we can write radical functions, especially with the square root. Also, we notice here in some of these that we have like a coefficient in front of the radical, and a added constant, the x variable in the back. So there are a couple of things we're going to have to do. The first thing is we're going to write an interval notation and then as an inequality. But what's nice about when we're finding the domain of a radical function, that we automatically get an inequality just from the process itself of finding the domain. So we're actually going to be able to do this column first with each function, and then we can rewrite the inequality as the interval notation. So just going through, let's start with the first f of x. So we'll call this one 1i. Um, if f of x is equal to the square root of 4x plus 10, then in order to find the domain, all we have to do is set the radicand greater than or equal to 0, right? So this is the radicand, don't forget, is the argument underneath the radical. So there's we should go and kind of note a couple of things back in our earlier algebra classes, right? Recall if n if we have the nth root of some radicand a, then if n is even, then the domain, it has to be larger than 0 or 0, right? So this means the radicand itself has to be greater than or equal to 0. Because don't forget, we can allow it to be 0 because the square root of 0 is 0, the fourth root of 0 is 0, but the square root of -6 doesn't exist in the real numbers. And we'll learn about complex numbers in a little while, but not right now. Okay, and then if n is odd, then the domain is anything, right? So is all real numbers. Because we could have a third root of a negative number, right? Like the cube root of -8 is -2 because -2 cubed is -8. So we can go ahead and have all real numbers if it's odd, but if that root is even, we do have a little bit of math to do. In this case, our root here is the square root. We don't always write it, but we know it's there, right? And because this root is even, we know to take that radicand and set it greater than or equal to 0. So let's go ahead and do that. All we have to do is take 4x plus 10 and set it greater than or equal to 0. So we just need to understand that when it's an even root, we just take the radicand and set it greater than or equal to 0 to find the domain. If the root is odd, then no worries, we just move on in life. But when it's even, we really have to be careful what we're trying to do. And we would just solve this as we always would. Sorry, I'll subtract 10 from each side. Right, this part is easy. It's kind of getting there is the challenging part. So then we get 4x greater than or equal to -10. And then if I divide each side by that coefficient of 4, I get x greater than or equal to -10 fourths. But we're in college algebra. We know to reduce that -10 fourths, right? We know that -10 fourths can be reduced by a factor of 2, right? So it ends up being -5 halves. So there's the inequality. So this is the inequality one. Now, how do we get this one into a interval? I usually like going from the inequality and doing a like mock number line, like super little, like this. And here's -5 halves. And then I'll read it to myself. X greater than or equal to -5 halves. X Greater than. I go to my number line. Where are numbers greater than -5? Mean larger than -5 halves? To the left or to the right? And it is to the right because we know that larger numbers are over here like 0, 1, 2, right? The positive. And because it's a or equal to, this is going to be standard when finding it. It's just part of the definition. So we're going to go ahead and just make it a bracket. And then I can go ahead and make the interval, right? I'm going to have a bracket. I'm going to mimic my number line at starting at -5 halves all the way out to infinity. So you can see here that we get the any interval first, and then we get the inequality by the default of just finding the domain. Okay, oops, here we go. So you kind of get that idea. That's just the process exactly. So for G, I'll call number 2, 2i, we have g of x equal to 8 square root of -18x minus 10. Like that. So I get a little flustered. I'm like, oh my God, there's a coefficient of 8 here. It changes this whole definition. And the answer is absolutely not. Problems may change, but methods never do. If this is the definition and the method will never change. We're going to take this radicand and we're going to go ahead and set it greater than or equal to 0. We'll learn later with transformations what this 8 actually represents and how it won't change the domain because it doesn't really affect the x's. Only what's in here attached to the x is going to change the x's. So here to find the domain in this one, I believe in the process. I believe problems change, but processes don't. So I'm going to take -18x minus 10, which is greater than or equal to 0. And once again, all we're doing is taking the radicand and following the definition. Now I'll go ahead and add 10 to each side. I'm just doing my usual. And we get -18x. The 10's cancel out. Greater than or equal to +10. And then what we're going to do is divide by -18. Now, when dividing by a negative or multiplying by a negative with inequalities, we know that we have to reverse the sign. This is super important. I want to highlight it that when you multiply or divide by a negative, you have to reverse the inequality symbol, okay, or it just won't make a true statement. So when we do this, we do get the 18s reduced out. We have an x, and now we have less than or equal to -10/18. And of course, we're in college algebra. We know that we should be reducing that. So we get x less than or equal to -5/9. So there's the inequality, and let's go ahead and try doing a mock of a number line. They don't ask for the number line, but I do this because it's so much easier to write the interval this way. So then now I read it, x less than or equal to -5/9. X is less than or equal to. Less than or equal to, where are numbers less than or equal to -5/9? To the left or to the right? Less than, smaller than, always to the left, right? Because the default is or equal to, an inequality symbol has the bracket. Now we know how to make the interval. We see that it starts at the arrow over here, which implies it's a negative infinity. And I say negative infinity because it's pointing to the left. Right? When it points to the right, I do a positive infinity, and that's kind of how we associate that. Comma, and then we stop at -5/9 and we put a bracket because once again it can be 0. So now what we do is we see that the interval we get directly from the number line. So sometimes we can, um, sometimes we get good enough at these things where we can just see it and convert it to the interval. But if you're still learning, like I am sometimes, I definitely like having the um the number line there. And I get practice with writing inequality, a number line, and also the interval. And I think that you, as a student, can do the rest. Once again, it's okay that there is an 8 added in here because when we get to transformations, you'll see that it doesn't affect the x's. The only thing that affects the domain are anything that's attached to the x. So that's why the radicand is so important in all of these. So in these last functions f and p, all you're going to do is the same process. And if you multiply or divide by a negative with the inequalities, you just reverse the symbol. If you don't, like we didn't do in 1i, we just divided by a positive 4, nothing changes. Notice nothing was changed. It's only when you have a negative or multiply or divide by a negative, it changes the inequality symbol. But other than that, I leave to the student the rest, and I hope this helps.